In this video, we are going to do a few numericals from calorimetry. So let's see the first question. How much heat energy is released when 5 gram of water at 20 degrees Celsius changes to ice at 0 degrees Celsius? So like I told you, water directly doesn't convert to ice. First of all, the temperature will drop and then it will convert to ice. So the first step which happens is that water at 20 degrees Celsius will convert to water at 0 degrees Celsius. First, the temperature will decrease till 0 degrees Celsius. So in this case, you can see the temperature is changing. So what amount of heat will be released? Q is equal to mass into specific heat capacity into the difference in temperature. I told about this in the previous video on my channel. So what is the mass? 5 gram. So I am taking gram because the values of specific heat capacity and latent heat of fusion are all in grams. So I am taking gram, I am not changing it into kg. What is the value of C? The specific heat capacity of water is given as 4.2 into del T. Del T means the difference in temperature. So it will be 20 minus 0. The value of del T will always be positive. We will not get a negative answer. So 5 into 4.2 into 20. Solving it, we get 420 joule. So the amount of heat energy released when water at 20 degrees Celsius is converting to water at 0 degrees Celsius. So 420 joule. Now this water at 0 degrees Celsius will convert to ice at 0 degrees Celsius. So water at 0 degrees Celsius will convert to ice at 0 degrees Celsius. So in this case, as you can see, no temperature change occurs. So the amount of heat released will be equal to ml, where we are considering the specific latent heat because no change in temperature occurs. So the mass is 5 into the value of L is given as 336. It comes up to 1680 joule. Now this is the total heat, the sum of these two. So the total heat will be, the total heat released will be 420 joule plus 1680 joule, that is 2100 joule. So now our next question is, 40 gram of ice at 0 degrees Celsius is used to bring down the temperature of a certain mass of water from 60 degrees Celsius to 10 degrees Celsius. Find the mass of water. So how do we do this? So over here we have considered that we have a beaker which contains water, let us suppose, and the water is at a temperature of 60 degrees Celsius initially. We have put 40 gram of ice into this solution, and this ice is at a temperature of 0 degrees Celsius obviously. So what will happen? The water will get cooled like we studied in the video previously. So what is the final temperature? 10 degrees Celsius. So this water which was initially at 60 degrees Celsius is cooled down to 10 degrees Celsius. So we have to find what was the mass of water in the container initially. So let's see. So whenever two substances are mixed, we know that the hot object will give out the heat and the cold object will take that heat, isn't it? So first of all, we will take the heat taken by ice. Ice will take the heat in order to melt and water will give away the heat in order to become cold. So the heat taken by ice. First of all, the ice was at 0 degrees Celsius, but after taking heat it will convert to water at 0 degrees Celsius. It will not directly convert to water at 10 degrees Celsius. So ice at 0 degrees Celsius first converts to water at 0 degrees Celsius. So for conversion of state without any change in temperature, we consider the latent heat. So over here, as you can see, our mass is in gram, but our values are in kg. So we will convert this mass of ice into kg first. So mass of ice is 40 gram. That means 40 by 1000 kg. So 1 by 25 kg is the mass of ice. So what will be the heat taken by ice? Let's see. Heat taken is equal to m into L, mass into the specific latent heat of fusion since no change in temperature occurs. So 1 by 25 into 336 into 10 to the power 3. Now what will happen? This water at 0 degrees Celsius will convert to water at the final temperature, isn't it? The water at 0 degrees Celsius will now convert to water at 10 degrees Celsius because 10 degrees Celsius was our final temperature. So let's write water at 0 degrees Celsius will convert to water at 10 degrees Celsius. So we can see there is a change in temperature. So we will use the formula for specific heat capacity. So our heat taken will be equal to m into C into delta T. So the mass of ice was 1 by 25. The value of C over here is 4200 joule. Del T 10 minus 0. So 1 by 25 into 4200 into 10 joule. So this is the heat taken by ice while converting to water at 0 degrees Celsius, and this is the heat taken by water at 0 degrees Celsius to convert to water at 10 degrees Celsius. So what is the total heat taken? This plus this obviously. So 1 by 25 into 336 into 10 to the power 3 plus 1 by 25 into 4200 into 10. If you solve it, you get a value of 15120 joule. You can solve it very easily. So this is the total heat taken by ice. Now what is the heat released by water? So water, which was initially at 60 degrees Celsius, is converting to water at our final temperature. What was the final temperature? 10 degrees Celsius. So water at 60 degrees Celsius is converting to water at 10 degrees Celsius. So see, temperature difference occurs. So we will use the formula for specific heat capacity. So what is the heat released? M into C into del T. We don't know the mass of water, so we will keep it as M. The value of C for water is 4200. And what is del T? 60 minus 10. That means M into 4200 into 50. So as we know from the principle of calorimetry that heat released is equal to the heat gained. So what was the heat released? M into 4200 into 50, and the heat gained was 15120 joule. So now if we solve it, our M will become 7.2 into 10 to the power minus 3 kg or 72 gram. So this is the mass of water which was initially present in the container. So this is our third question, similar to the previous question. A piece of ice of mass 40 gram is dropped into 200 gram of water at 50 degrees Celsius. Calculate the final temperature of water after all the ice has melted. So over here we have the value of mass of water and the value of mass of ice. We also have the temperature of water, but we want to find the final temperature of water after all the ice has melted in it. So let's see. So over here we can see the values are in gram, but our specific heat capacity and latent heat of fusion is given in kg. So we will convert these masses into kg. So first of all, mass of ice is equal to 40 gram. That means 40 by 1000 kg. So 1 by 25 kg. Similarly, the mass of water, it was 200 gram. So 200 by 1000 kg, 1 by 5 kg. So as we know that the hot object will release its heat and the cold object will take the heat. So in this case, what is going to take the heat? Ice, obviously. So let's see. Heat taken by ice. So first of all, the ice is at 0 degrees Celsius. It will convert to water at 0 degrees Celsius. So let's write. Ice at 0 degrees Celsius converts to water at 0 degrees Celsius. So see, the temperature is same. That means we have to use the specific latent heat formula. So we know the heat is M into L. So the mass of ice was 1 by 25 kg and the value of L was given as 336 into 10 to the power 3. So 336 into 10 to the power 3. This amount of heat is taken by ice while melting. Now this water, which was at 0 degrees Celsius, will convert to water at T degrees Celsius because we don't know the final temperature, so I am considering it to be T. So water at 0 degrees Celsius is converting to water at T degrees Celsius, our final temperature. So this is the water which was formed by melting of ice. So we have to consider the mass of ice, not that of the water. Make sure you are considering this nicely. So what is happening? The temperature is changing. That means we have to use the formula for specific heat capacity. So how much heat will be taken? Q is equal to m into C into delta T. So the mass of water or the mass of that ice was 1 by 25 kg into C is 4200. In the question it was mentioned as 42000, but it will be 4200. This is the correct value. And del T is T minus 0, because obviously this is lower than T. So T minus 0. So 1 by 25 into 4200 into T joule. This is the heat taken by water at 0 degrees Celsius to convert to water at T degrees Celsius. So what is the total heat taken? One by 25 into 336 into 10 to the power 3 joule plus 1 by 25 into 4200 into T joule. So if you solve the first part, you will get 13440 plus 168 T. So this is the total heat taken by ice to convert into water. Now the water which was already there in the container, that will convert to water at the final temperature. So it will release some heat. So heat released by water. Water which was already present. So the water was initially at 50 degrees Celsius. So water at 50 degrees Celsius will convert to water at T degrees Celsius. So T is the final temperature which we have to find. So obviously 50 degrees Celsius will be more than T degrees Celsius because the temperature of water has decreased. So see, temperature difference occurs. So we have to use the formula for specific heat capacity. So the heat which will be released will be equal to m into C into delta T. Here we will use the mass of water. So what was the mass of water? 1 by 5 kg into the value of C was 4200 into del T is 50 minus T. So if we solve it, we will get 840 into 50 minus T. So according to the principle of calorimetry, we know that the heat taken will be equal to heat released. That means 13440 plus 168T will be equal to 840 into 50 minus T. So we have to solve it. If we solve it, we will get 42000 minus 840T. Now this is a simple linear equation. If you solve it, you will get the value of T as 28.3 degrees Celsius. So this is the final temperature of our mixture. Our last question is, let us say 40 gram of water at 60 degrees Celsius is poured into a vessel. The vessel has a mass of 1 gram containing 50 gram of water at 20 degrees Celsius. The final temperature is recorded as 30 degrees Celsius. So what happens? We have a vessel. So in this case, the vessel has a mass. That means we have to consider the energy which is taken by the vessel also. Now in this vessel, we had 50 gram of water. 50 gram of water at 20 degrees Celsius. And in this water, we have poured 40 gram of water, but which was at a temperature of 60 degrees Celsius. That means we had cold water with us, but we have added hot water into it. So the hot water will lose heat, but this cold water and also this vessel will gain heat. So let's see. Heat lost by hot water. So what happens? This water at 60 degrees Celsius was converting finally. What is the final temperature? It is 30 degrees Celsius. So water at 60 degrees Celsius was converting to water at 30 degrees Celsius. So see, temperature difference is occurring. So we will use the formula for specific heat capacity. So the heat is mc del T. The mass of water was 40 gram. So 40 into, for water it is 4.2 into, what is del T? 60 minus 30. So the higher temperature minus the lower temperature. So 40 into 4.2 into 30. So we are getting 5040 joule. This is the amount of heat which is lost by the hot water. Now who is gaining the heat? This cold water which is already there, that is gaining the heat, and also the vessel, that is also gaining the heat. Why we are considering the vessel? Because the mass of the vessel is given, and also our question is we have to find the specific heat capacity of the vessel. So the vessel will also be considered in this case. So now heat gained. So who is gaining heat? First of all, the cold water. So water which was at 20 degrees Celsius first is converting to water at, what is the final temperature? 30 degrees Celsius. So water at 30 degrees Celsius. So see, there is a temperature difference. So our heat will be equal to mc delta T. What was the mass of water in the vessel? 50 gram. So 50 into 4.2 into 30 minus 20. The larger minus the smaller. So we are getting 50 into 4.2 into 10. That means 2100 joule. Now heat is also gained by the vessel. So what is the heat gained by the vessel? Again, mass into C into delta T. We have to find the value of C. The mass of the vessel was 1 gram. C into, so the vessel was also at a temperature of 20 degrees Celsius along with the water inside. So this is only the change in temperature. So 30 minus 20. So how much we are getting? 1 into C into 10. That means 10C. So these two are the heat gained and this is the heat lost. So as we know, according to the principle of calorimetry, heat gained is equal to heat lost. So we have 5040 is equal to 2100 plus 10C. So from here, if you want to find the value of C, we will get the value of C as 294 joule per gram per degree Celsius. So this is the specific heat capacity of the vessel in which the water was there.